Okay, welcome back. So we talked about in our last videos the unit circle and how you can layer it together to get all the special angles. They're radian measures, their degree measures, which we did on the template, and their coordinates. And now we're going to talk about how to use these coordinates in order to evaluate trig expressions for these special angles on the unit circle. And we're not going to use a calculator, we're just going to use this unit circle to find the exact values. So the coordinates, when you look at these coordinates, the x coordinate of any of these points is going to always be the cosine of the angle theta. And the y coordinate is going to be the sine of the angle theta. Right? And you want to write that down in your notes because that's super important. One of the ways that you can remember which one is which is they go in alphabetical order. So just like x comma y is in alphabetical order, cosine comma sine is in alphabetical order, and these correspond. Okay, the other thing you want to know before we get started on examples is that the tangent function is equivalent to the ratio of the sine of the angle divided by the cosine of the angle. So, and when I look at these coordinates, I don't need to know anything other than that x and y because I can come up with the tangent using the sine and the cosine, which are the x and the y. Okay, the secant function, SEC, remember, is the abbreviation for secant. That is the reciprocal of the cosine. So again, to find secant, all I need is that x value because cosine is the x, and I take the reciprocal, and then I've got it. The cosecant, CSC, of the angle, that's the reciprocal of the sine, and that's the y value. So I can find secants of any of these special angles by taking the reciprocal of the y value. Cotangent, COT stands for cotangent of the angle, is the reciprocal of tangent, and reciprocal, remember, means to flip that fraction up and down. So the cotangent, if I flip the sine and cosine positions, is defined as the ratio of the cosine of the angle over the sine of the angle. And that's all of my trig functions, right? I can find the cosine, the sine, the tangent, the secant, the cosecant, or the cotangent of any of these special angles, any angles that are coterminal with them, just by knowing these coordinates on the unit circle. So we're going to go ahead and work through some examples now and see how amazingly easy this is if you know your unit circle. So say I wanted to find the sine of 5 pi over 4. Okay, that means I want, because it's the sine, I want the y coordinate at this angle's terminal point, 5 pi over 4. So I look at my circle. The pi over 4s are the green. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and there's 5 pi over 4. The sine is the y coordinate, which is negative square root of 2 over 2, and that's the answer. Negative square root of 2 over 2. And it's that easy. Okay, let's say I wanted to know the cosine of negative pi over 6. Okay, remember, negative angles go in the clockwise direction. So instead of going counterclockwise to pi over 6, because that would be a positive angle, I'm going to head clockwise in the negative direction. So from 0, I'm going to go to the very next purple, that's negative pi over 6, and look at the x coordinate, which is square root of 3 over 2. That's the cosine. So square root of 3 over 2 is the cosine of negative pi over 6. Okay, if I want to know the tangent of let's see, let's do tangent of 5 pi over 3. Okay, now remember we put some notes here on the side. The tangent is defined as the sine of the angle over the cosine of the angle. So to find the tangent, I need the y over the x. So I'm going to first find my terminal point at 5 pi over 3. So if pi over 3's are the orange, this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. And this ratio is going to be, to find tangent, the negative root 3 over 2 divided by 1/2. So we'll write out that ratio, negative square root of 3 over 2, that's the y coordinate, divided by positive 1/2. And when you divide fractions, remember you multiply by the reciprocal. So I'm going to flip this second fraction. That becomes a 2 over 1. Then when I reduce, my 2's will cancel out, and I'm left with negative square root of 3 divided by 1, which is just negative square root of 3. And that's the tangent of 5 pi over 3. Okay, so far so good. Let's try a secant. So let's say I want to know the secant of 7 pi over 6. Okay, so if I look at my little cheat sheet I made, the secant, here it is the reciprocal of the cosine. So I need to find the x coordinate, that's the cosine, then take its reciprocal, and that's for 7 pi over 6. So on my circle, the pi over 6 are purple. So we'll count in increments that big. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. And 7 pi over 6 is right here in the third quadrant, and we need its x coordinate, which is negative square root of 3 over 2. So I need the reciprocal of that, so I'm going to do 1 divided by negative square root of 3 over 2. And remember, reciprocal just means to flip that fraction. So we're taking 1 times the 2 over negative square root of 3. And 1 times anything is just itself, so that won't do anything. But we do have to rationalize the denominator to simplify. So in the numerator, we have 2 square root of 3. And then in the denominator, square root of 3 times square root of 3 is the square root of 9, which is 3. And that's a negative. And so that's our answer, right? The secant of 7 pi over 6 is negative 2 root 3 over 3. Okay. Now let's try a cosecant. So CSC stands for cosecant, and we want to find the cosecant of, I don't know, let's do cosecant of 3 pi over 4. Okay, so cosecant is the reciprocal of sine, so we need to know the y coordinate, and 3 pi over 4 is our green triangles here. So we have 1 pi over 4, 2 pi over 4, 3 pi over 4. The y value there is root 2 over 2. So we want to take 1 divided by root 2 over 2, which is 2 over square root of 2. Then we're going to rationalize that denominator, and we're left with 2 root 2 over 2. And these 2's here are going to cancel, and that'll simplify to just a positive square root of 2. So the cosecant of 3 pi over 4 is exactly the square root of 2. Okay, now let's go ahead and do a cotangent. And let's pick a negative angle. So if we want to know the cotangent of, let's say, negative, I don't know, we're going to pick something. So negative 5 pi over 4. Oh, no, that's going to be too easy. Let's pick a harder one. Let's see, let's do cotangent of negative 7 pi over 3. There we go. That's trickier. So if we're looking for negative 7 pi over 3, and negative angles go in the clockwise direction, so we're going to start here at 0 and count backwards around our circle. So this is negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3, negative 6 pi over 3, negative 7 pi over 3. And remember coterminal angles, right? This negative 7 pi over 3 has the same terminal side as 5 pi over 3. They're coterminal angles. So they're going to have the same coordinate, and that's a negative root 3 over 2 for the y and a positive 1/2 for the x. So cotangent, since that's going to be the cosine over sine, that's the x over the y. So we'll have a 1/2 for the x divided by negative square root of 3 over 2 for the y. And then to divide fractions, we multiply by the reciprocal. So 1/2 times, and then negative 2 over square root of 3. And our 2's cancel, leaving a negative 1 there in the numerator. So negative 1 over square root of 3. And we're going to rationalize that denominator. And then we'll have a negative square root of 3 over 3. And that's the cotangent of negative 7 pi over 3. Okay, so went through those pretty quickly, but that's one example of each: sine, cosine, tangent, secant, cosecant, cotangent for angles in radians. And you can go ahead and message me if you have any questions. I hope that helped.